Hi, I'm Alex and I'm a H1 chemistry student. So today we're going to be going through a titration question between ethanoic acid, which is found in vinegar, and sodium hydroxide. So this is a very standard question one that you'll see on near to all exam papers. So it'll nearly always be question one. So it's a nice consistent one that you can learn off all your titrations and you know it's going to come up very consistently. So I'll start running through the important parts of this question and highlighting where you should really focus with this one. So since we know that this is a titration between ethanoic acid, which is found in vinegar, and the sodium hydroxide, we know straight away that there's going to be a dilution, and that's exclusive to this question for the Leaving Cert. So for this titration, you always dilute the vinegar just so that the reaction happens more accurately and that the volumes can be recorded more accurately as well. Straight away in the question, as I've underlined here, a 10 centimeters cubed portion of the vinegar was first diluted to exactly 50 centimeters cubed. So what I'd be noting straight away is that there's a 5 times dilution in this question, and that's going to be essential for the calculations later. I'd also just, while going through this first paragraph, there's a lot of information there, lots of words. So I'd always recommend going through and just underlining the important information, pulling it out of here and then writing it down yourself on your answer booklet. You can see it all in front of you a lot easier than just in the paragraph form. So I've also underlined here that the diluted vinegar, the 10 centimeters of the vinegar, which was diluted to 50 centimeters cubed, the diluted vinegar was titrated against a 0.09 molar sodium hydroxide solution. So I'll write down there, sodium hydroxide, 0.09 molarity. And then on average, 12.4 centimeters cubed of diluted vinegar, that's important, that's the diluted vinegar, were required to neutralize 25 centimeters cubed of the sodium hydroxide. So I'll be writing all this down straight away so that you know exactly where you stand going into this question. Okay, so part A of this question is very nice. It's just about the equipment used, the apparatus used, and processes. So really just definitions and step-by-step processes that you have learned off well in advance of the exam, and that will always be consistent for this experiment. And then part B is looking for you to calculate the volume of the undiluted vinegar. So that's why it's going to be important that we take into account the dilution factor in this question and also outline an advantage of diluting the vinegar. So part B is all about the dilution of the vinegar. And then part C of this question is just about the indicator used and the colour change that's observed. And then finally, into part D will be your calculation, the bulk of your calculations for this question. So I'll be looking for the number of moles, maybe the masses or the volumes or whatever else is needed for this question. So that's where a lot of your figures will come in and your calculations will come in. That's the last bit of this question, and that's where the bulk of your marks will be found. So we'll dive straight into this question now, and we'll start with part AI. So now, getting into part I, they're looking for the piece of apparatus used to accurately measure the original vinegar. So when you hear accurately measure, you're immediately going to go for something like a pipette or a burette, which are both accepted answers in this occasion. I prefer this over the other accepted answers. This year they also accepted graduated cylinder and syringe. However, you know from yourself from doing these experiments that a pipette and burette are very accurate pieces of equipment. There's very little error, and all error is accounted for through using the apparatus. So I think they're a much more suitable and a much safer answer to put down for this type of question, as opposed to a graduated cylinder and syringe. And then for either writing pipette or burette, and they also accepted this year, as I said, the graduated cylinder or syringe, you would receive 3 marks for this question. And now for part II of this question, it's asking you to describe how this piece of apparatus was rinsed before use. So this is similar for all pieces of apparatus used for the titration questions. You always wash with deionized water first, and then the solution that will be going into the piece of equipment. So as I've said here, you rinse firstly with deionized water. Make sure you say above the 0 mark, because you want to make sure that all the surface area that will be used and that will be taken off by your solution is all cleaned. You want to make sure the entire piece of equipment is cleaned before using it. So that's why I've noted here the above the 0 mark. This year you got away without saying it, but it's always a safer option to say this. And then for part 2 in this question, you rinse it with vinegar. For any other occasion, you rinse with whatever solution is going into the equipment. This here is vinegar. And now for the marking for this question, for saying to wash your first rinse to be with deionized water, you will receive 3 marks, and then to rinse with vinegar, you will also receive 3 marks. But really nice 6 marks to pick up. So now the third part of this question, part III, it's asking you to describe a suitable method to dilute the 10 centimeters cubed of the original vinegar to 50 centimeters cubed, which will be used for the experiment. So I like to always do these as steps. So I have step 1 here, which is just to add 10 centimeters cubed of the original vinegar to a 50 centimeters cubed volumetric flask. There are the measurements given to you. So you know you're going to be starting with 10 centimeters cubed. Just fill that into this, I want to call it a generic formula that you can use for any dilution, whatever the volume of the vinegar is or whatever you want to dilute it to, because it does change every question every year. So some questions will have you do it like this, or it might change from these ratios. So depending on the year, just fill it into this generic formula. And then for the second step of this method, you fill the volumetric flask with deionized water until the bottom of the meniscus sits on the graduated mark when reading from eye level. So I've underlined here the important bits. So it's important that you say that the bottom of the meniscus is sitting, because that's where it's measured from. So you know that's exactly 50 centimeters cubed then. And make sure you mention graduated mark. Both of these are very important points. And the third point that is very important as well is that make sure that you're reading from eye level. All these steps ensure that your titration is accurate and your measurement of the 50 centimeters cubed is exactly 50 centimeters cubed. Then for writing out these 2 steps, so step 1, mentioning the volumetric flask and the original vinegar, you'll receive 3 marks. Then for the second part, the second step, mentioning the bottom of the meniscus and the graduated mark and reading from eye level, receive an additional 3 marks. So a really nice 6 marks to pick up in the exam. I'm just going back to the question. So we have part AI done, AII, and AII done for the 15 marks for part A. We get straight into part B now. So getting into part B of this question, so it's asking us to calculate the volume of undiluted vinegar you're required to neutralize the sodium hydroxide. And lots of people find that this will be the most difficult part of the question, not so much as it's actually difficult, but just to wrap your head around the concept of it. So you're working with a diluted solution in this. You have 1 part of diluted vinegar, 4 parts of water, deionized water. We know this since we've used from the previous question 10 centimeters cubed of vinegar and filled it into 50 centimeter cubed vessel. So the other 4 parts are going to be, the other 40 centimeters cubed in this case, is going to be deionized water. So there's 5 parts in total in the solution. So for every 5 parts of the solution, 1/5 of that is the original vinegar. That's really the important thing to get your head around in these questions with the vinegar, is that it is diluted. So you're going to have to be reverting back to the amount of original vinegar used, and that's going to be very important for your calculations later on. So when the vinegar is diluted like this, when there's 1 part of the total 5 parts, you can say that has a dilution factor of 5. So that means that there's 1 part out of the 5. If instead of using a 50 centimeters cubed metric flask, we used a 100 centimeters cubed volumetric flask, it would be a dilution factor of 10, because 1 part of the 10 parts of solution is vinegar, is the original vinegar. So now, to reiterate what I said above, so I'm going to do here a ratio between the original vinegar and a diluted solution. So 10 centimeters cubed to 50 centimeters cubed. So that's a 1:5 ratio. The 1 part of the 5 parts of solution is the original vinegar. But in our case, we don't have 50 centimeters cubed, we have 12.4 centimeters cubed of diluted vinegar. So we know that something multiplied by 5 would give us our 12.4 centimeters cubed. So the 12.4 is the 5 parts, and we need to find the 1 part of original vinegar that's in that diluted solution. So I hope that makes sense to you. in order to get that, in order to work out the amount of original vinegar in the 12.4 centimeters cubed, we simply just divide by 5. It's no different to the case of the 50 centimeters cubed to the 10 centimeters cubed, that ratio. If you divide 50 centimeters cubed by 5, you'll get the 10. So in our case, if you divide the 12.4 centimeters cubed by 5, you'll get our volume of original vinegar. So now to calculate this, you just throw it into your calculator. So 12.4 divided by 5. Then in this case, I will just get it in a decimal form since it looks a bit cleaner. That'll give you 2.48 centimeters cubed. So 2.48 centimeters cubed of the 12.4 will be the original vinegar. Your marking for this question, you'll receive 3 marks for stating that 2.48 centimeters cubed of the original vinegar is required to neutralize the volume of sodium hydroxide. So you receive 3 marks for that, and you'll also receive 3 marks for implying or referencing the dilution factor, which in this case is 5. So you receive 6 marks total for this question. And as I said, for these questions, it's the trickiest part to get your head around, but kind of once you get an understanding of it and once you do a few of them, you'll pick it up fairly easy. So now, part 2 to this question, they're asking us to name one advantage of using the diluted vinegar. So why are we going through all the trouble to dilute the vinegar and work out its dilution factor and all that process? One of the reasons here is that you can get away with using a less concentrated sodium hydroxide solution. So this is beneficial because you'll get more accurate results and the volumes will be greater, so it'll be easier to do your calculations at the end. Also, less concentrated sodium hydroxide is easier to attain for the laboratory, so it's definitely beneficial for this reaction to dilute the vinegar. So for the second part of this question, they're just looking for one advantage of dilution vinegar. So why we're going through all this process of dilution vinegar and working out the dilution factor and all of that? Simply, less concentrated sodium hydroxide solution is required for the titration. Nice and easy, you just learn that off. It'll work always for this question if this question is asked. So we'll move on now to part C of this question. Now, just going back to the main question. So we calculated the volume of undiluted vinegar, the original vinegar required to neutralize the solution. That's part A done, and we got 6 marks for that. And then for the second part, an advantage of diluting the vinegar, we also got 3 marks. So that's part B, completely done, dusted. That's another nice 9 marks. It's quite a tricky bit to get around that part B, but once you get an understanding of the dilution factor and how the dilution happens, nice easy marks. Now we'll dive straight into part C. So this question is all about the indicator used. So in this case, part A, they're looking for a suitable indicator for this titration. So we know that sodium hydroxide is a strong base, that ethanoic acid is a weak acid. So for any titration or reaction with a strong base and a weak acid, phenolphthalein is always the best indicator to be used. So for these, we always know that phenolphthalein is always the best indicator to be used. Then for part II of this question, they're just looking for the colour change observed at the end point of this reaction. So once you know that equilibrium has been reached, what is the colour change? So it goes from pink to colourless. They don't accept clear, they don't accept anything like that. It has to be pink to colourless. They're the only 2 options there. Then the marking for this question, so you'll get 3 marks for stating phenolphthalein for the indicator used for this titration, and then you'll get 6 marks. So 3 marks for stating pink, and then the colour change to colourless, you'll get another 3 marks for saying colourless. So that's a lovely 9 marks to pick up. Really quick, really easy marks to pick up for this question. Now, so that's part C of this question done. So we mentioned our indicator and we stated our colour change. Really nice, easy, quick 9 marks to pick up for this question. We're getting into the bulk of the question now with our calculations. So we'll get straight into those and we'll reference back to the paragraph at the start where we're given all our values for the titration. So now getting into our calculations questions. So part I, we're asked to calculate the number of moles of sodium hydroxide in each 25 centimeter cubed portion. So you know with these straight away, we're looking for the number of moles. We're talking about titration question. We're going to go to our favorite formula, N equals volume in liters times molarity. So we're already given our volume, but it's in centimeters cubed. Now, the trickiest part about this question is just to get your volume in litres. So we know we have 25 centimetres cubed. That's given to us in the question. And we know there's 1,000 centimetres cubed in a litre. So to convert the 25 centimetres cubed to litres, all we do is just divide across by 1,000. So you divide across by 1,000, all you're doing is moving the decimal point. So that's how I like to do these questions. It's always nice and easy. So since we see there's 3 zeros, you move the decimal point 3 times to the left. Now, moving the decimal point, we jump over the 5 once, over the 2 twice, and then once more for 3 times because we have 3 zeros. Since there is no number here, we fill in a 0 and we move our decimal point over to here. So it's moved to the left 3 times. That will tell us that our volume in litres is equal to 0. Then just what we have here, 0.25 litres. So that's the easiest and nicest way to work out what your volume is in litres. So now working out our number of moles, N, we plug in our value for our volume in litres, which we've just worked out at 0.025 litres, and then multiply that by our molarity, which is given to us in the question. So we'll throw this into a calculator and we'll work out our number of moles. So now just throwing that into the calculator, we have 0.025 litres multiplied by 0.09, and this will give us our number of moles. So if we move that to a decimal, 0.00225 moles. So that's the number of moles of sodium hydroxide in each 25 centimeter cubed portion. Now you have 0.00225 moles of sodium hydroxide in each 25 centimeter cubed portion for this titration. So for this, you'll receive 4 marks for the correct answer. We'll move on now to the second part. Now, on to the second part of this question. It's asking us to calculate the number of moles of ethanoic acid in each centimetre cubed of the diluted vinegar. It's important that we see the diluted vinegar there. So straight away, when you see one of these questions where you're comparing something you know, something you don't know, you're going to do a ratio. So we look at the equation and we look at the ratio between the sodium hydroxide and the ethanoic acid. In this case, it's nice and easy. We have 1 sodium hydroxide to 1 ethanoic acid. What this tells us is that the number of moles of sodium hydroxide will be equal to the number of moles of ethanoic acid. As we worked out in part I, we have 0.00225 moles of sodium hydroxide. So that means we'll also have 0.00225 moles of ethanoic acid. However, in this question, they're asking for how many moles in each centimetre cubed of the diluted vinegar, not just how many moles in total. We know from the question that we have 12.4 centimetres cubed of diluted vinegar reacting in this titration. So we know that there is 0.00225 moles of ethanoic acid in that 12.4 centimetres cubed. So simply divide across by the 12.4 and that'll give you the amount of moles of ethanoic acid per centimetres cubed. So just say that again. So just to get the number of moles per centimetres cubed, we know that there's 0.00225 moles in 12.4 centimetres cubed. So how do we get 1 centimetres cubed? We simply just divide across by 12.4. So 0.00225 divided by 12.4. So just throw this into the calculator and you'll work out how much moles is in each centimetre cubed of diluted vinegar. Now just throwing that into our calculator. So we have 0.00225 moles. So we throw this into the calculator. And if we change this just to a decimal, we know there's 0.000181. So usually just at 3 decimal points or even 2 decimal points is usually okay. You're better off being safe and just going to 3 decimal points. So when we divide across, we're given an answer of 0.000181. So you want to go to at least 2 significant figures. So I'd go to the 1/8 and round off the 1, which would just go down to 1/8 anyway. So we're left with an answer of 0.00018. Now for calculating the number of moles of ethanoic acid in each centimetre cubed of diluted vinegar, which we worked out to be 0.00018 moles per centimetre cubed, you will receive 4 marks. This is quite a nice question, really. There wasn't a whole lot of work in it, and to get 4 marks out of it, you wouldn't mind that at all in the exam. Now we'll move on to part 3 of this question. Now they're asking us to calculate the concentration of ethanoic acid in the original vinegar in moles per litre. So we're starting off here, and this is not the original vinegar. This is the diluted. Just make note of that when you're going through the question. This is the diluted moles per centimetre cubed. So to get to moles per litre, first we'll just get the diluted version and then we'll work on getting the original. So we know that there is 1,000 centimetres cubed in a litre. So to get from centimetres to litres, you literally just multiply across by 1,000. So like we did earlier with dividing, all you can do here is just move your decimal point. So multiply it by 1,000. And by moving your decimal point, you move it to the right when multiplying, unlike how we did it earlier where I moved to the left. So move decimal point once, twice, 3 times, and we'll have 0.18 moles per litre. But this is the diluted solution. This is the diluted vinegar. Now, if we remember back to the start of the question when we were working out our dilution factor and what the volume of ethanoic acid was of the original vinegar in the solution, you remember we divided by 5. However, since now we're going in the opposite direction, we're going from diluted to original, we multiply by 5. If there's 0.18 moles of ethanoic acid per litre, the diluted, we know that the original is a lot more concentrated. So of course there's going to be more moles per litre in the original. So it has to get bigger. We know from the question that there was 10 centimetres cubed per 50 centimetres cubed. So that again gave us our dilution factor, of 5. So to get our moles per litre or our molarity of our original vinegar, all we do is get our moles per litre of the diluted and multiply by 5. So 0.18 multiplied by 5 will give us our molarity of our original vinegar. So we'll throw this into a calculator and we'll get an answer out straight away. And we have 0.9 moles per litre, our original vinegar solution. Now for calculating the concentration of ethanoic acid in moles per litre in the original vinegar, firstly we received marks for multiplying our dilute solution by 1,000 to get that in moles per litre. We got an additional 2 marks for working out our concentration of ethanoic acid in the original vinegar solution. But we'll work on now to part 4 and the final part of this question. Now, the final part of this question, they're asking us to calculate the concentration of ethanoic acid in the original vinegar in a percentage of W/V, which is weight to volume. So we know when you're talking about weight to volume, this will be the number of grams per 100 centimeters cubed of that solution. Straight away, we know we have to go back to our favorite formula for these types of questions. To work out our mass, we're going to be using the formula N equals M over MR. So we'll get straight into that now. So now to calculating the MR, we'll come back to the mass in a minute, and we have the number of moles already. So we're going to calculate the MR of our ethanoic acid first. So simply go to your periodic table, or you can go to the front of your booklet on the day and all your molecular weights will be written down for you. We'll go through this together, and I always advise writing out every step of this and don't just throw it into your calculator, because you can still receive marks even if there's a calculation error. Write it out fully. Going through this, CH3COOH, that's our formula for ethanoic acid. So that the molecular weight of carbon is 12, and we have 3, so 3 times the hydrogen, which is 1. Then we have another carbon, so another 12, and oxygen, 16 each, so plus 16, and then finally a hydrogen at the end, so plus 1. So now just throwing all that into our calculator, we will get our answer of 60. So 60 will be our molecular weight of our ethanoic acid. Now the only other thing we need to work out for the equation to work to use this formula is our number of moles. We know that we have 0.9 moles per litre of ethanoic acid in our original solution. But in this question, we're looking for 100 centimetres cubed, since we're looking for a percentage of weight to volume. So how do we get from litres to 100 centimetres cubed? All you do is just divide across it by 10. So 0.9 divided by 10 will give us 0.09 moles per 100 centimetres cubed. It's going to be our N. Now all we have to do is manipulate our formula a small bit and work out our mass, and then we'll be able to find our percentage. Now we know we have our N, which is equal to 0.09. We have our MR, which is 60, and we're looking for our mass, since we need to find our percentage in mass per volume, so number of grams per 100 centimetres cubed. So we go back to our favourite formula for these types of questions, N equals M over MR. But since we don't know our M, we want to isolate that. So we manipulate it slightly and we get N multiplied by MR will give us M. So if we write this down, 60 multiplied by 0.09 will give us our mass in grams. So if we throw this into the calculator, we'll get 5.4. So that tells us that 5.4 grams of ethanoic acid per 100 centimetres cubed. So we'll throw this into our weight to volume and we'll find out our percentage. So now going back to our weight to volume percentage, we know that it's how many grams there are of the solute per 100 centimetres cubed. We've calculated here that there's 5.4 grams of ethanoic acid per 100 centimetres cubed in the original vinegar. So now we just fill this in, so 5.4 grams per 100 cm cubed, and that tells us that it's 5.4% weight to volume, and that's your answer for this question. So then the marking for this question, for calculating your MR to be 60, you will receive 2 marks, and then for getting your weight to volume percentage, you'll receive an additional 3 marks. So that's it for this question. Go back and make sure that we have everything done. So now that's all of part D done. So we did part I, II, and IV. So that's all 4 points for a total of 17 marks. So in general, this is a very standard titration question, very common to see, and calculations were very nice the whole way through. That's it for this video. I hope you found it helpful.